We start experiment number 10. Here we observe the system steady state error and its response against disturbances. So we use Matlab here. Now you already know what is steady state error. So this is the difference between the input and output of the prescribed test input. Now we use final value theorem to calculate it. Now here we have task 1 that you have to do it yourself, that it is basically pre-lab, so that you revise your basic concepts, then you will start this lab. Now task 1 is that answer the following questions. What types will yield zero steady state error for step input, and so on. We have actually around 7 questions here. Now basically where we have to do implementation is for part 6, but you have to do it on page by yourself, then you will verify it using Matlab. Now here we have, for the negative feedback system of figure 1, GFS is given, HFS given, so we have to calculate the steady state error in terms of K for the input 5 UT, then 5 times the ramp, and then 5 times the parabolic input. So similarly for question number 7, you have to do it for actually here is the extra integral come in with same question number 6. Similarly another integral come in. So actually 6, 7, 8, 6 is type 0, 7 is type 1, and 8 is type 2 system. So you have to do it on paper. After doing that, then you have to move to task number 2. Now task number 2 is basically what we have to do in Matlab, is that task 2 is using Simulink. So it is specifically tell you to use Simulink to set up the negative feedback system of question 6. Plot on one graph the error signal of the system for an input of 5 UT for K variation, that is 10, 15 and 100. Repeat for inputs of ramp and parabolic. So compare the steady state error. So the main idea is that you have to fill this table and you have to identify that what happened if you increase the gain. So what happened on the steady state error, and you actually in task 1 you calculate it yourself. You have to compare the results of both them, then explain the reason why there's a difference in higher. Okay, so you have to do it and complete this. How you do it? You have to open Matlab. So if I open Matlab, so first of all what I have to do, I open a script file, because it's mentioned that you have to use Simulink, but still I open script file. And in script file what I did actually, I do very simple thing, and I just clear it, close it, and then clean the screen, and then introduce a transfer function, because the transfer function G of S that is given in task 1 part 6 is something like this. So I just want to know the root. So what I did, I just put here the transfer function, and I get this numerator and denominator. Now from this numerator and denominator I make a Simulink file. So first is task 2 here. What I did, I make 3 subsystems. So first one is for step input, second is for ramp, and third is for parabolic input. So task 2 effort of gain on steady state error. So if I open the step input, what I did, I just put this transfer function that I calculate in using script file, and then I put the gain value here is 10. For second I put 50, for third I put 100. Now after that, this is the error. I just want to see error here, and I also put a display here so that I need to fill the table. So I take a feedback. Now I multiply by step unit with 5, again 5, and again 5, because this is for step input with 5 times the gain of the step, that is 5 u of t, so that's why I put gain values 10, 15 and 100. So when I run this code,